Hello and welcome. Today we're doing a question from LeetCode called delete node in a linked list. It's a medium. We're going to jump right into it. There is a singly linked list head and we want to delete a node in it. You were given the node to be deleted. You will not be given access to the first node of head. All the values of the linked list are unique and it is guaranteed that the given node is not the last node in the linked list. Delete the given node. Note that by deleting the node, we do not mean removing it from memory. We mean the value of the given node should not exist in the linked list. The number of nodes in the linked list should decrease by 1. All the values before node should be in the same order, and all the values after node should be in the same order. And we have some custom testing over here, but example 1. So we have head being 4, which points to 5, 1, and 9. This is our linked list. And we want to remove node 5. So our linked list in the end would go from 4 to 1 to 9 to none. And example 2, again, we have the same linked list, 4, 5, 1, 9, and none. We want to remove node 1. So here it's going to go from 4 to 5 to 9, then to none. And some constraints. The value of each node in the list is unique, and the node to be deleted is in the list and is not a tail node. So it's not the last node of the linked list that we're given. Okay, so how are we going to do this? Usually when we want to delete a node, what we typically do in a linked list is go to the node before the one we want to delete and just change the next pointer. So say I had the following example, 4, 5, 1, 9, none. This is my linked list, and I want to delete node 5. What I would usually do is go to node 4, change its next pointer. So instead of pointing to 5, it points to its next node. So it looks something like this, where the next pointer, instead of going to 5, goes to its current next node value. So it goes directly to 1. So it would go from 4 to 1 to 9 to none. And that would be removing node 5. But we're not given access to the first node of head. All we're given is the node that we want to delete. And this is a singly linked list, which means all we know is our current value and the next node. So we know all the nodes in our linked list that start from us and then go till the end. We have no knowledge of what's before, so we can't do this pointer manipulation where we go to the node before us and just change that pointer. So how are we going to delete this node? We need to get a little creative with it. Okay, say we have the following input linked list, right? We have head being 4, which points to 5, which points to 1, to 3, to 6, to 9, to finally none. And we want to remove node 5. What would that end linked list look like with node 5 removed? So that's going to go from 4 to 1, we skip over 5, 4 now points to 1, to 3, to 6, to 9, to none. Now if you notice something, right? If we compare our original linked list to this new linked list over here, all the values are just shifted. We have 3 here, but the original 3 was here, 6 here, the original 6 was here, 9 here, the original 9 was here. So what we're doing is basically moving the values down to the left by 1. So if this is the node that I'm given, this is the node that I want to delete, I start over here, right? Node represents now the node that I am on. So if this is the node I'm on, I want to take the value of my next node. So I check what my next node is and I have access to that. That's going to be value 1. So I'm going to put value 1 into my own node's value. So now this is going to be 1, and then I'm going to go down to my next node. And I'm going to check what the next value is, put it in my own value, and keep doing that all the way through. And if you see, we're building the same linked list we have down here. Then I come here, I make this 9, move this down, and this is none. I now point this to be none. So essentially, what we've done in this linked list is just removed that node. We've changed the values and gotten rid of a node to basically have a behavior of removing node 5 entirely. Now, to make this a little bit more efficient, there is something else that we can do. Feel free to pause this video and give it a shot yourself, just to figure out how we can do this in O of 1 time and space. So what we're doing is changing all the values, right? And I'm gonna go back to my original linked list that I had over here. So this is my original linked list. I have 4, 5, 1, 3, 6, 9, and none, and I wanna remove node 5. What I'm doing is changing the values, right? And the reason I can't do pointer manipulation is because I have no access to the nodes before me. But once I change values, right? Once I have my node taking my next node's value, so it's taken 1 over here, well, now I can just remove this node directly. There's no need to move everything down. I can just now have 1 point to its next value, go from 1 to 3 directly. And that's going to look something like this, right? I take my 1's next pointer and point it to my next node. So it's going to go from 4 to 1 to 3 to 6 to 9 to none. If you notice, what we've actually done is just removed the node we didn't need. What we're gonna do is take the value of the node after us, and we know that that's not going to be none, right? We're guaranteed that the given node is not the last node in the linked list, can't be this last node, which means it has to be anywhere before then. So we can take the value of the node after us and then change our pointer so our next pointer points to our next value. So let's go ahead and code this up and then run through a super quick example. Okay, to code this up, what do we want to do? The first thing we want to do is take our node's value and change it. So we're given the node that we want to delete, and we want to assign its value to be our next node's value. So node.value is going to equal node.next.value. And now we want to do some pointer switching. So we're going to have our next node point to our next node. So node.next is going to equal node.next.next. And that is it. So let's go ahead and submit this. And it is accepted. So space and time complexity, space, we don't use any other space. We are modifying this in place. So that's going to be O of 1 constant space. And for time, all we're doing is 2 operations. So this is going to be O of 1 constant time as well. And if we want to run through this with example 2 right here super quickly, we have 4, 5, 1, 9, none. And we want to remove this given node here, right? This is our input node that's being passed in. What are we doing? We're doing node.value, so the value that we have right now, and setting this equal to node.next.value. So this is now going to be 9. And node.next, so what are we pointing to? What's our next node over here? This is now going to equal node.next.next. So now this is going to equal none. And we've basically gotten rid of that node over here. So now we have 4, 5, 9, and none, which is exactly what we were expecting. So we just went ahead and solved delete node in a linked list. If you have any questions whatsoever, of course, let me know down below. I will answer all of them. If this video was helpful, like, comment, and subscribe. It really supports the channel. And as always, I will see you in the next one.